Hello, in this lesson, we like to talk about absolute value function. We like to recap on that, actually recap on absolute value function, and then we're going to talk about absolute value equations. Okay, so we're going to recap first. And recall that we have done these work before in week 1. Okay, in the first week, we talked about, the absolute value function, which is right here. Okay, absolute value function, the properties of absolute value functions, and we went over examples on absolute value functions, and we did a graph, and we plotted the points. Excuse me. And this time, we're going to recap on that. And then we're going to go over the, what is absolute value equations, okay? Okay, so let's see what we have covered, right? In those lessons, we covered the properties of absolute value functions, right? And we talk about some do's and don'ts, some common mistakes, and we also talked about the graph of the function. We talk about the statements, right? The absolute value of a non-negative number is the same as the number, and the absolute value of a negative number is its opposite. So we've talked about those. And we did examples, of course, and we did the graph. Okay, we did the graph. And so here is the graph. So here's the graph. Where is it? Right here. Okay, so we plotted the points for absolute value function. And right, so I'm going to bring this over to our current lesson. Let's see, I'm going to put it here, right? So this is the graph, right? And we also have gone over so that's from the absolute value function. We have talked about the property we can use, okay? We can use these properties. Okay, we can use these properties, which is right here, right? And the properties we cannot use, okay? And the properties we cannot use. So let's go back there, okay? The properties we cannot use, such as this is false, right? This is false. Okay, so these are the common mistakes. Okay, common mistakes. Common mistakes, right? That's what we did. And what else there is, right? The two sentence, right? The statement, the two sentence statement we did, right? Which is here, okay? The absolute value of a non-negative number, okay? The absolute value of a non-negative number is the same as the number, okay? Put it on the top, because this graph tells us exactly that, okay? The absolute value of a non-negative number, right? So input, output. So from the graph, it tells us that narrative. For example, the absolute value of a non-negative number, suppose the input, right? This is the input, and that's the output. Okay, the absolute value of 1.9 is the same as 1.9. The absolute value of 0 is 0. And the absolute value of a negative number, say -3, is going to be the opposite of it. Okay, this is a -3. Okay, the absolute value -3, and this is 3, and this is 3, right? So the absolute value of a -3 is 3, and 3 is the opposite of a -3. And of course, 3 is also negative of a -3. Okay, so we have gone over that. Okay, so that's the recap for absolute value. And today we're going to talk about the if statement involve these functions. The if statement. For absolute value. The if statement for absolute value function. Okay, we understand that as an absolute value function, right? As absolute value function, we have this function, right? And suppose I put away this table, right? If we are given the input, right? The function goes like this. The function goes like this. Let me see. How come I have so little space here? Okay. This software has some issues. Okay. At least I cannot resolve it. It also just move around, so leave less space for me to type. Oh, geez. Maybe better just give up. All right, so this is better, but it's not the best. Okay, so let me change the fonts to be 150%. So let me see if I can move that. Okay, anyway, it's a little bit better. When we are given an input, right? You know the function relationship, input X and go through this function, right? So this is the function which is a rule, right? This rule of the function, it produces an output, which is going to be the absolute value of the function. Input is horizontal measurement from the origin. Output is the vertical measurement from the origin, right? Still the same idea. So when input is given, right? For example, if I say f of 2, right? Input is given. For f of 2, the absolute value of 2 is 2. The absolute value of positive number is the same as the number. Geometrically, for the input given, right, we will draw a vertical line. We'll draw a vertical line. Okay, so we're going to draw a vertical line. Okay, for input that is given. Okay, so we draw a vertical line. This vertical line crosses the curve, crosses the function graph at one point. It should be exactly 1 point because it is a function, right? For each input, there's exactly one output. So at this point, the input is 2, right? And the output is positive 2. Okay, input, output. So knowing input to find output, we draw vertical line. But what if we know the output? What if we know the output, right? Just like what we did before, right? Sometimes we know the output if the output is given, okay? If the output is given. For example, a typical question would be like this, right? Solve for X, right? And the question would be like this. the absolute value of x is equals to 2. Okay, this is very typical of a question. What does it mean? What does it mean? This actually means that the rule of the function, on the rule of the function, okay, we don't know the input, but we know the output. The output is 2. The output is 2. If the output is 2, right? If the output is 2, then we're looking for input, okay? So the meaning is to identify all possible input, okay? It could be plural. Inputs, x, okay? Such that the absolute value of those inputs would be equals to 2. Okay, so the absolute value of x equals to 2. So that means if the output is 2, right? So this is where the if statement say. And we can also say if the output is 2, right? If the output for the function is 2, identify all possible inputs. Identify all possible inputs. So that's how we interpret it. Okay, that's the interpretation. With that interpretation, graphically, we will be drawing horizontal line. We'll be drawing horizontal line. Okay, we'll be drawing horizontal line, just like what we did before. When output is given, we draw horizontal line. So this time, instead of drawing that vertical line, and this time we're going to draw a horizontal line. And this horizontal line crosses the curve, crosses the graph of the function at two places, And this tells us there are 2 inputs for the same one output. Okay, this tells us there are 2 inputs or 2 solutions for that output requirement. Okay, and of course, you guys know the answer. Okay, it is the interpretation here that we must understand. We must understand. Okay, so what are the inputs? What are the inputs? I will write it down how you show your work. So the inputs, there are 2 inputs that give us the solution, right? One of the inputs is -2. Okay, and the other input is +2. Both input will give us the same output 2. Therefore, there are 2 solutions. Okay, so input, okay, so input a -2 is a solution. Input a +2 is a solution, right? And they have the same output. They have the same output. Horizontal for inputs, vertical is for output. So that's the interpretation. Right, so once again, if we know input, we draw vertical line. If we know output, we draw horizontal line. And this graphic method is very powerful. It can be very powerful. If you use it, it will tell you how many solutions to expect and where they approximately are. Okay, approximately are. In this case, we see the precise value. Okay, but in some cases, the answer may not be as easily identified precisely. Okay, so if you want a precise value, we still have to resort to algebraic methods. That's why algebraic methods is used very often as well. Okay, and to the point that sometimes we actually don't even use the graphic method, because the graphic methods doesn't always give us the precise value. All right, Okay, so with this understanding, right? So we can say the solution would be x equals to +2 or -2. And question solved. How do we show work? How do we show work? Right, so I'm going to show you a couple ways, some of the ways you might have learned before. So this is the function perspective, okay? So let me organize our work for this question. Solve for x, right? Solve for x, and where the absolute value of x is equals to 2, right? We just explained the meaning, right? So one method, the first method, okay, the first method, you would be drawing this graph, right? You draw this graph and you identify, this nature of the question. You draw the graph, so you identify the 2 points, right? So then you get your solution already. Okay, you get your solution already. Then you can say the solution is x equals to +2 or -2. And you're done. You're finished. Okay, if you use this method, preferably that you draw this picture to demonstrate to the reader, Excuse me. The second method. The second method maybe is most commonly taught method. Okay, the second method may be the most commonly taught method, right? Still for the same question, instead of working in the 2-dimensional, we work by the definition of number line, the absolute value, right? We use the definition of absolute value. What is the definition of absolute value? Right? What is the definition of absolute value? The definition of absolute value, okay, this means, right, the distance between a number we don't know, between x to the origin, which is 0. That's what it means. On graph, what does that mean? Okay, so let me draw a graph. Let me draw a graph for you. Right here, okay? So I'm going to graph it in such a way that you're going to see you're going to see the number line. You're going to see the number line, okay? And I'm going to make the view. Okay, so that's going to be like that. Okay, and something like this. Okay, and we don't want to show that 0.5. Let's see if I can make it not show 0.5. Yeah, this is what I want, right? So you just see the number line, pretend, and this is the 0, right? This is the 0. What I'm going to do. Okay, there, right? So this is the number line, that's 0. So distance between, so we just work on the number line. Just work on number line, okay? Remove the y. I don't know how to get rid of it, okay? Just leave it there. So distance between x to origin. We don't know where x is, but we know where origin is, right? So then from here, you measure to the left, -2. The distance between -2 to 0 is 2, right? And the distance between 2 to 0 is also 2. So we basically look at these 2 distances, right? From origin, we measure 2, distance 2. And from origin, we measure distance 2, right? So we end up with these two numbers. And these two numbers, of course, are going to be our solutions. These two numbers are going to be solutions, right? Now, okay, so these two numbers, by definition, right, the absolute value of x is equals to 2, and we do the measurement, so x equals to positive 2 or negative 2. Okay, so that's how we do it. And this is the method that was taught most of the time. Okay, so I'm going to put the points on the graph so it doesn't move by with me. Okay, it doesn't change. So I'm going to put these two numbers in place. Okay, so one is a negative 2. Right? So I'm going to put it as a red dot. And the other one is a positive 2. So these two dots are solutions, and the distance of each number, okay, to 0 is 2. Okay, the distance is 2. So this is the algebraic way of doing it without using function. And this is what's mostly taught. Okay, this is mostly taught by most of the literatures, okay? But since we discuss function, so we also see the function perspective, okay? We also see the function perspective. Now the question is, how do you show work here? How do you show work here? Okay, so in this case, in method 2, if you use method 2, no problem, right? How do you show work? I'm going to show you exactly how you show work. That's the question, and that's your work. Show work. That's it, just 2 lines. Do you have to draw the picture? It'll be good if you do. If you don't, that's fine too. It's optional, okay? It's optional. Okay, so this picture is optional. Of course, having it is nice. Okay, and that's it. Are there other methods? I think these two are the major methods. These two are major methods. And next it comes to other situations. Okay, and next it comes to other situations. For example, you might see another question, right? So did we have example 1 earlier? Okay, at least I like to name it example number 1. Okay, example 1. Example 1. Okay, then let's look at example 2. Okay, example 2. For example 2, right, we have another situation. I'm still going to talk about these two methods. Right? It's still solve for x, of course, right? And here we have absolute value of x equals to 0. What will be the solution? Function method. Okay, method 1. Just be patient with me, okay? I believe most of you know the answer. I believe most of you know the answer when you watch this. But I do want you to be patient with me, okay? In this case, okay, similar to the first example, because this time the output is 0. So the horizontal line will cross, okay? The horizontal line will be what? What will be the horizontal line? The horizontal line is going to be y equals to 0, right? Last one was y equals to 2 because the output was 2, right? Last time, the horizontal line was 2. Y equals to 2. And this time, oh, sorry. Okay, the horizontal line was 2 if the output is 2. Now, if the output is 0, of course, y is going to be 0. So this time we're going to draw the broken line. Zero. And I'm going to make it red so that's visible. That's visible. Right? You can see that red line crosses the curve at exactly 1 point. What does this tell us? This tells us there's only one solution. There's only one solution. And what is that solution? That point of intersection, right? The horizontal line crosses the curve and there's only 1 point at that point of intersection, and that point has a coordinate, right? That point has a coordinate. That coordinate is 0, 0. The first 0 is the input. Input is what we're looking for. The output is 0. So when input is 0, output is 0. Therefore, the solution in this case, x is 0. X is 0. Okay. How do you show work? Just this one line. If you draw the picture, will be nice, right? Will be nice. So you can see graphic method tell us roughly sometimes how many solutions to expect, right? It may or may not tell us the solution precisely, but it really tell us how many solutions can be expected. So this is the advantage of having the function perspective, okay? And this technique is often used, especially in these days and time. Graph is so easy to it is so easily accessible to us, okay? The second method 2, right? For method 2, okay, I'm gonna borrow that picture we did earlier. Okay, so let me just clear it, right? That picture, right? So now, of course, the previous answers are not going to be relevant. The previous answers are not going to be relevant. So I'm going to remove those dots. Okay, I'm going to remove those dots. Just this number line. And because we're solving this equation, right? We know the absolute value equals to 0, right? So a number, the distance between an unknown number to 0 to origin is 0, of course, is going to be 0 itself, right? So the solution is just going to be x equals 0. If you want to put a dot on the graph, and that's what you can do, okay? You can just put a dot on the graph. Okay, so you can just put a dot on the graph and that red dot. So these two methods. Okay, and one more. Example number 3. Suppose I want you to solve for x. Okay, and this time x is taken absolute value, and it is equals to -1. Now, a -2. -2 is fine. Why not? How about -3 then, right? We don't want to keep using 0, 2, so we can use -3 sometime. We can use even decimal numbers or fractions and so on and so forth. Okay. In this case, if you use method number 1, it will be really, really interesting. Okay, so I borrow this picture still, right? Previously, when the output is 0, we draw y equals to 0. When the output was 2, we draw a horizontal line y equals to 2. Now the output is -3, right? So x given to the function right? Which is absolute value. And it produces the output. The output is a -3. So we're going to draw the horizontal line y equals to -3. Do you see the parallel or similarity of these questions in nature, right? So I'm going to draw -3. And of course, you're not going to see that picture. You're not going to see that picture because I need to make adjustment to the picture, right? From -4 to 5. Look at that. The horizontal line, y equals to -3. Y equals to -3, which is the output. Okay, which is the output, does not touch the graph. Does not touch the graph. What does that mean? What does that mean? No touch, no solution. No touch. So you can say no solution. No solution means what? There's no input such that the output is -3 for this function, f equals to absolute value function. Okay, and algebraically, okay, method 2, you can also make a statement here. Okay, you can also say, you don't have to draw the picture, you can say, okay, the absolute value of any number, this is the range of absolute value function, right? For any real number. For any real number x. Okay, so this absolute value of any number is greater than or equal to 0. Of course, it will never be equals to -3. Okay, so this is actually quoting the range of the function, the absolute value function. So now, if you recall, what do we talk about, the domain and range for this function? Very, very useful, right? That range. So this is really the one sentence statement we covered before, right? Domain and range. And range for what? For the absolute value function. Over here. Domain and range for this function. Okay. So that's the 3 types of questions. That's the 3 types of questions. Okay, so we basically have example 1, example 3, example 2, and example 3. Okay. Now, so let's look at these 3 cases. Let's look at these 3 cases. Okay, we'd like to do a summary. We like to do a summary. There are 3 cases. 3 cases. Okay, summarize. Okay, solving. Okay, we're going to put these examples in our 3 cases. We are 3 cases, right? It could be solving for x, right? And solving for the case that's equals to 0, the output equals 0, right? Or the output equals to negative. And you look at these 3 cases. Okay, so I'm going to put this outside. Solving for x, right? If you look at these 3 cases in graph, right? This is the graph for equals to 3, right? Equals to 3. And this is the graph for equals to 0, right? And one more graph, and this is the graph that for equals to 2. Okay, if the output is a positive number, you have two solutions. So the solution is the two solutions. And let's also draw those other pictures here, right? And this is for 0. Right, so let me make it just a little shorter. Oh, what's going on? There, better. All right, and for 2, we have the 2 here, right? There we go. Make it just a little bit shorter, okay? So this will make it so much easier to compare, right? Equals to 2 equals to 0 versus 0, right here, right? Equals to 0. And the other case, there's no solution, right? So it will be just an empty number line. There's empty number line. So if we really want to have a picture there, we can just put a picture there. There's nothing there. Okay, so I'm going to remove that picture. I'm going to remove that dot. Because this is the case that, wait, what's going on? Hello. This software has a little temperament with me, huh? Let's see, I need to remove that dot. I need to remove that dot. Right, because there's no solution. There's no solution here. So if you look at all 3 cases, right? So I'm gonna make it a visible on one screen, right? You look at these 3 cases. You look at these 3 cases, okay? Equals to 2. Maybe I should make this picture just a little lower, right? Like that. Like those. All right, so in this case, there are 2 solutions, right? So x equals to +2 -2. In this case, just x equals 0. And in that case, it's going to be what? X, no solution, no solution. No solution. Okay, with these 3 models being covered, we are going to see variations. We're going to see variations, okay? For example, these 3 models can totally become more complicated. Imagine this x is a little complicated expression, okay? X become a little complicated, right? So I'm going to copy and paste this picture. I'm going to copy and paste this picture, right? I can totally have a question, right? They ask you, say, hey, solve this, right? Solve for absolute value, okay? 2x minus 1 equals to 2. How about that? Solve for x, solve for x. Can we do it? Of course we can, right? Of course we can. So what we do here is that we see this model, don't we? We see this model. We have this model. We have this model. Okay, so I'm going to bring this model, right? So instead of x is 2, right? Now we have 2x minus 1. So I can view this piece. Hold on. I can view this piece as omega, right? So omega. So this is about omega. And so the answer will be omega. Do you see that? So omega equals to 2. Omega actually is, I just hide it. So I know the whole process. Right? So when I actually handle this omega, right, which is 2x minus 1, and that equals to 2, what I will do is that I know omega, right, because this is my omega, right? That's my omega. Okay, this is my omega. Okay, so omega equals to plus 1. I'm sorry, plus 2 minus 2. And I have my omega to be 2x minus 1, right? 2x minus 1. So omega equals to 2x minus 1. And here we go. We ended up with 2 other equations. Okay, with 2 other equations. And you can write it separately, equals to 2 or 2x minus 1 equals to negative 2. Okay, so then we just solve these 2 equations separately. So 2x equals to 3, and we end up with x equals to 3/2. Okay, and the other one would be 2x equals to what? We add 1 on both sides equals to -1. So as a result, right, x equals to -1/2. X equals to -1/2. And there we go. And there it is. Right? You can see from these compact model, we can develop other things. And how do we show work? Right? This is how you show work. Do you have to show these pictures? No, you don't have to, but you should have those pictures in your mind. Okay, so when you show your work, that's all you need to show. You have 2 solutions. Okay, so let's look at another model. Okay, another example number 5. Okay, and this time we're going to solve for what? I'm going to make up the solution, right? I'm going to make up the absolute value. So we saw that solving the previous equations, right, with the absolute value. So let's look at another example. Suppose I solve for x, right? But this time I'm going to have like 2x, we probably could change, right? 5x minus 3 equals to 0, right? Which model would this fit? Well, this model, right? X equals 0. Hold on. Okay, so this model will fit in our situation, right? So we basically treat this as baloney or just omega, right? You can see the symbolic, right? This omega. So when omega equals 0, so when we set up, right, when we solve this equation, we know the output is 0. So when the absolute value is 0, which is omega equals to 0, right? So that's my omega. And that's, if that is true, right? Omega would be 0. Omega itself is 0. And of course, our omega is 5x minus 3. So 5x minus 3 is 0. Then we just have to solve for x, right? So 5x equals 3, divide both sides by 5. So x equals to 3/5. Right? How do you show work? And this is how you show your work. That's it, right? So to show work for this question, that's the solution. That is a solution. Do you need to draw the picture? No, you don't. But you should have that picture in your mind. You should have the picture in your mind. Okay, so let's look at another example. Example number 5. Example number 6. Okay, for example number 6, let me have another one. So for x, right? And in this case, you probably guessed it, right? We have a 5x minus 15 equals to -7. Okay, now, which model will fit? Of course, this one, right? Of course, that one. This model will fit. Okay, it's just this is going to be omega. Omega equals to -7, right? The output is -7. And in our case, the omega is 5x minus 15. Okay, the 5x minus 15. Okay. The question is that the absolute value of anything, right? The absolute value of any real number is at least 0. So including this piece, okay? That's what it means. The absolute value of anything, no matter how complicated, how simple, okay? For any omega, okay? And therefore, this is no solution. This is no solution. So these are the 3 models that you will encounter, but with the function perspective, right? With the function perspective. So let's look back the 3 models, right? Let's look back at the 3 models, right? So x is just one symbol, right? X is just one symbol. It could be omega, right? It could be 2, it could be 5, could be 3.7, it could be 10, it could be 3.6, right? It could be any number. The idea is the same. And this omega, this x can be any quantity. If the absolute value omega equals 0 and the scenario is similar, so that omega is going to be 0, right? So this omega is going to be, so this x is really a placeholder. I hope you see that. This is a placeholder, a holding the place. So with the function perspective, I think really the function perspective can sometimes give us a lot of insight, okay? And of course, as we talk about, it has its pros and cons, okay? The cons is that sometimes we can only identify how many solutions to expect, but we cannot identify the precise value, okay? Especially for numbers, say omega equals 3.7 or 7.69. Those are the values very difficult to identify. But the picture, okay, the picture of the function definitively can give us a lot of insight, okay, give us a lot of insight. So that's all for this lesson, okay? If you have any questions, please do not hesitate to reach out to me, and thank you for watching.